just wanted to go through the onboarding and see what we can do for free, and then see what we can do with a paywall, okay? Or behind, like whatever is behind a paywall. Let me just, yeah, cool, perfect. Okay, so we've got this guy here. I'm Koji, your personal tutor. Um, I don't. Do we put voice? Let's put voice. Everyone's sleeping. But we can try to put some voice. And I'm gonna put the speaker here so you guys can hear, because I don't. I have this connected. So let me see. Do I have this connected? Yeah.
Learning is just asking what if and following the trail.
Ready to learn? Let's go figure something out.
Okay, so essentially it's male and female.
Sounds good. I'm here to help if you ever get stuck. I won't give you the answer, but I'll point you in the right direction. Just like a tutor sitting next to you. Let's get started.
And that's, I guess that was one of the major critiques from the Math Academy guys, that this pointing in the right direction is maybe not the best thing to do. Because like, unless you make sure that the student actually really is challenging. Let's put it this way. I'm not against providing the solution if I know the student is going to actually try to understand why that solution. And I get it. I get that for kids, that is not obvious. So you want an environment where that doesn't happen, because kids are kids. Kids haven't actually grown up enough to understand that. And so kids will not have that reflect of trying to understand really why, deep enough. And so you want something that doesn't give them the answer. But now, giving them a direction, and I'm a father myself of 3 kids, and sometimes when I'm trying to teach them basic math to our oldest daughter, she's 7. She just is about to finish her first year of primary school, and they just do basic stuff, right? Addition, subtraction, and it's almost like you're tempted sometimes to give them a nudge, but you can see that they don't fully understand the nudge. You know what I mean? It's almost like saying, and this is maybe very simple, but it's almost like saying, it just think of the simplest thing, which is, let's go to Scarlet Draw and let's draw something else here. So this is the simplest thing, right? A plus B equals C, right? And just the simplest concept of trying to explain to a child why is it okay, or it's easy to explain with these, with subtraction, right? And you know, there's this methodology where you explain to the child first stuff in like 2 or 3 different levels. First is actually stuff attached to the real world before you move to symbolic, right? So you talk about apples and something that eats. You have 10 apples, right? You have 10 apples, and then a hungry caterpillar eats 5 apples. So how many apples there are left, right? And then you sometimes you kind of like, if you try to explain to the child intuitively that if you know that they can actually do the reverse operation, they could take 5 and then count how much there is left to reach to 10, right? They don't understand. Like, the reaction is not like, oh, let me go try this, right? Like, they're missing, because they're missing one thing, which is they're missing the concept of how to learn. Like, they're missing the fact that you know that you're given, as a grown-up, you know that you've given an answer. You're not learning. You actually need to break this down. You need to understand really why that answer makes sense, right? You can use whatever techniques you want, breaking it down 5 whys, whatever. It doesn't really matter. There's a bunch of techniques and whatnot. But that's one thing I think that's where the critique is going here. That the hints might actually not be the right way to do these.
What do you want to learn first?
I think I'm gonna do. It's funny they just computer science and coding. So here they brag about the fact that they're not going to teach you actual programming. They're going to teach you actually just how to understand code, which is okay. Like how to understand the concept of computation. I think that's kind of it makes sense, in my opinion. But let's do math, because math is a bit easier to go through.
Now, what level of math are you currently at?
Okay, we will be honest, right? And we will just go with calculus because I want to do something. I want to see if it can teach me actually something useful that I don't know of. You know what I mean? Like I want this testing that I'm gonna make with it to be genuine. But again, I'm biased because I'm a grown up and I know how to learn, right? I know how to learn, and I know that a child would have a different experience. And then if they advertise this as like kids education, let's go up here, calculus. I understand. I mean, I want to start from the basics. I can use variables and solve equations. I can make and interpret graphs of equations, and I understand derivatives and integrals.
And where do you want to start?
So, okay, so we've got advanced algebra, for some reason is recommended, and calculus. Strong foundations are important for calculus. Okay, let's go with the recommended path, advanced algebra.
Got it. We have everything you need. I know right where we should start. From here, there's no limit to how far you can go.
Okay. I hope you can hear him well.
You're all set. Let's start learning.
So, I mean, okay, I think I know most of this stuff, right? I mean, that's obviously more like trigonometric functions, yeah, polar coordinates, yeah, complex numbers, yeah, polynomials. I mean, I know this stuff on the surface, right? I don't know if I'm gonna learn something niche that I don't know, but let's just focus on the experience itself for now, okay? See, that's the problem. This is like sometimes like learning is not necessarily like this. You don't really feel it's like if you're going to the gym, you don't feel stronger every day. It's very interesting because it's very similar to like working out, right? Where for the first 2 weeks you're like, whoa, I start working out, I feel awesome. Then the actual problems start. How to stay connected, stay engaged, grind through the lectures, do the work, and this kind of stuff. Let's see.
Welcome to trigonometric functions. You'll explore patterns that repeat over time. Mark the points where the search volume reaches its peak of 9 million.
Okay, so it asks me straight away a question. And okay, I cannot like. Okay, so many systems naturally exhibit behavior that repeats over time. Mark the points representing instances of the peak search volume of 9 million. Leap year searches in millions. And so this is in millions, and so I guess one will be a 2 and another one would be a 6, right? So, okay.
That's right.
And we can speak to it. Hello?
Hey there. Nice work on those first few points. Are you ready to see how this pattern continues?
What if I say no?
No problem. I'm here whenever you're ready to dive back in. Just let me know if you have any questions.
Can you tell me what the best tool for online SEO is? I just want to see if it actually. Okay.
Let's focus on that for now.
Okay.
Ready to continue?
Okay. So actually, they have some basic. There's some basic layer there. Sorry. Yeah. Yeah.
Notice how the peak of 9 million repeats every 4 years? This horizontal distance between identical points is called the period.
Ah, okay. So it actually taught me something now. Repeats every 4 years. Okay. So can I ask you why? I mean, that's interesting. At least you
Peak
can.
years occur every 4 years, so the search volume spikes like clockwork. Looking at the graph, the tallest peaks reach exactly 9 million at year 2 and year 6.
Okay. But now I can't ask it why anymore. But okay. Okay, cool. Let's just go on.
Now, assume the pattern continues.
Oh, okay. So assume that the pattern continues. Mark the next peak of 9 million. So we're going to do 1, 2, 3, 4. Here. Yeah. Right? Yeah.
Bingo.
Okay.
This time, focus on the smaller peak.
They seem very. One thing I'll say is that I'm not so sure how deep this goes, right? Because we're already like a decent amount in. Okay, let's see. Assuming that the pattern continues, mark the next peak of 3 million. Well, if the pattern continues, then it's here, right?
Correct.
Can ask you why, continue.
Here's the key idea. The function f of t that outputs search volume for the term leap year repeats every 4 years. What? A function that repeats its outputs in a predictable pattern is called periodic. Does that make sense?
Yes. So listen now. Yeah, that makes sense.
Great. Since the pattern repeats every 4 years, we say the period is 4. Ready to try. Look adding this on the next page. Now a different data set. At what times did the volume of searches for Olympics reach its peak?
0.5 and 4.5, I guess, right?
Yep. Use the graph to fill in the blanks.
That's all. Summer Olympics generate a peak of 6 million searches, and Winter Olympics generates a peak of. Oh, wait, what is this? Olympics. What? Why do I have to assume that Summer Olympics? That's odd. Do I have to assume that this peak is summer and this one is winter? You know what I mean? Like, why is this even trying to tell me? Let's ask. How do I know which peak is summer and which peak is winter? I mean, the graph just says Olympics searches.
Great question. Since the summer games usually draw more interest, which of the two spike heights on the graph do you think represents summer?
Fair enough. I mean, I have to tell you that that's not bad at all. I mean, this is quite Socratic. This is quite like it didn't really tell me it didn't really give me the answer. It gave me another question with a bit of a hint. Okay. Um. So. Oh, so I can actually answer here. Which one of these do you think represents summer? The taller peak.
Spot on. Now, looking at the shorter peaks on the graph, what is the search volume for the Winter Olympics?
I mean, sure, it could be. Sure, it has to be 4, right?
Exactly. Now, for the final blank, how many years pass between one Summer Olympics peak and the very next one?
So 1, 2, 3, 4.
Spot on. A full cycle takes 4 years. Go ahead and drag those values into the blanks. Good.
Not bad. I mean, I'm being honest.
All right, let's make a prediction using the pattern.
So the pattern continues. What will be the search volume during summer of 2008? Okay, so this is years since 2000. Oh, I can't move. Okay, so I'm in 2008. So that's gonna be basically this peak, right?
Boom. All right, last one. Let's try a different time.
If the pattern continues, so that's gonna peak in summer, then it's gonna go down here, then it's gonna peak here, and it's gonna, I think we're just basically here, right? I cannot go below. I cannot go here to the middle. Wouldn't actually be here because it would be this pattern exactly, right? So it would be to the peak 6, then down 2.5. Yeah, okay, no, and then here. So that's the winter ones.
Nailed it. Every single one.
Okay.
Many phenomena are naturally periodic. Using periodic functions, you can model repeating phenomena in the real world. Even though patterns don't always repeat perfectly, periodic functions can help you make predictions about what might happen next. Any last questions?
Okay.
Time for a quick skill check.
Skill check. Am I gonna fail? If the pattern continues, when world is equal 8. Okay, so there is in between that, there's basically 1, 2, 3, 4, and the 5 here. Okay, so there's a 3 checks. 1 will equal 3. So between 3 points is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 here. Okay. A different parameter function is shown below. The pattern continues. What is G? 9. Lesson complete. Sorry. I hope I didn't wake up anyone. Straight. I mean, I'm not too happy with all the gamification and this kind of stuff, to be honest. But it's okay. I guess for kids it's fun. You just qualify for hydrogen leak, keep earning XP to raise the ranks. Water leaks. Continue. What happened? Oh, sorry. The screen went down off. Okay, so personalized practice is only on premium. Learn more. What do I get? Daily lessons, free. Unlimited learning, full tutor support, no ads, jump ahead in personalized practice. Nah, okay. We'll continue with the free. No, I mean it's fine. Let's go. Let's actually pay. It's 25 bucks a month, bro. I don't want to pay for the entire year, and this is family. 28 a month, and you've got 6 seats included. Okay, that's actually worth it. Okay, guys, let me just turn that off for a second. See, I have to put some payment information. Okay. All right. So how do you hear about Brilliant? Why they don't have X? I mean, definitely YouTube, because Sabina has her thing here. Premium is better with the app. Let me go to the app. Okay, so we have these now. I'm number 8 on the Hydrogen League, which is probably all Keats. I mean, the thing is connecting gears, scientific thinking, probability and chance, polar coordinate plane. Fine, but I mean courses and what's all math foundations, algebra fundamentals, intermediate algebra. They changed the whole thing. Brilliant.org used to be completely different, actually. But where is the quantum stuff? Home, is there like really settings, algebra, intermediate algebra, advanced algebra, programming? What happened to like they had a lot of cool stuff about quantum computing and whatnot, science maybe here. What's because I could be on the night channel. Okay, yeah, quantum. Oh, they do. Okay, it's here. We could also do these. That's quantum computing. Okay. Explain it visually, science, logical reasoning. I guess we just have to try a few more. Technology and then how AI works, digital circuits. I think okay. I'm gonna wrap it up here for now. We've done the introduction. It's a bit late. Now actually flying today in the morning. Today, like in a few hours. So, but I'll come back to these. Now that I've paid for these, I need to actually do these. So far, it just feels more entertainment, as in like, I mean, I don't know. Maybe because it was just an introduction, but like, there's no like actual like so far like hard problem. And I think because of the style as well, which is very visual, that is what kind of makes it a bit difficult, right? But okay, let's give it a shot. Okay, wrap it up here, and see you tomorrow. So far, not bad. I mean, there was that moment where I asked it why. Well, I asked it like how would I assume which ones are somewhere in Olympic, and it actually just answered back with a question, which was actually good, because it gave me a question that made me think through these a bit more, right? Because I was afraid of making an assumption, right? I'm like, should I make that assumption or should I make that assumption? I almost kind of had forgotten that the x-axis was representing years, right? And obviously I could just think of it and I could just have thought about it and said, okay, so the Olympic Games happen every like 4 years, right? But then there's like but then every second, like, but every 4 years and shifted by 2, they're the Winter Olympics. They don't tell you that in the exercise, but it's something you can assume. And I was kind of like afraid of making the assumption, and the tutor kind of helped me do that. Not bad, not bad at all. Again, behind these there is an LLM, obviously, right? And I still think essentially that's one of the biggest sort of mistakes that these systems are making to actually put an LM. It's what you can do now because it's a technology that works, which is fine. But we have to work on a world model for education. Um, Something that actually triggers an actual interaction with you as a learner, right? To keep you fully engaged, like when you're driving your car, you're fully engaged, right? Anyway, see you guys tomorrow.